we live yet? It says excellent connection. Hello everyone, how are you? Oh, we are live, nice. Or what? Double loony. Oh. Let me check. Oh yeah. Discord. Here we go. I muted myself on Discord now. Hello everyone. So many people here. What's going on? Weather too cold outside? Yeah, Europe is suffering right now from the return of the winter. Why? How do I close the emojis here? I don't want this emoji stuff. Okay, anyways. Hello Adam, hello Christian, hello Dutch, hello Max, Sniff, Foo, and Bleep. And Adam number 201, Rota and Sergey. Wow, a lot of people already there. So you are here to see a mega cluster. Where do I have here? Yeah, it's disassembled. Superclusters. We had problems programming last time. Since then, a lot has happened. So I managed to reprogram the small ICs here. Not all of them. I have one segment that is refusing to be programmed. 0 to A6, okay, yeah, unfortunately that's not the topic for today. We are doing a Risc-V supercluster stuff, not ASIC design, unfortunately. Oh, I have a suggestion. You go to Simple Electronics podcast, and there you will find in the latest episode, I hope it's online right now, let me check. Sample, does it ever what? Cluster lizard? What? Let me check. Where is the podcast? Oh, there is like an extra tab in okay, here we go. Where is the one? It's not online yet. Nope, it's not online yet. But it will be. So subscribe to Simple Electronics, and I will be talking about. I have like 1.5 hours. I had a chat with Dan yesterday. About also the ASIC stuff. Was quite interesting, about renovation, about cars, car repair, stuff like that. So gardening a little bit. So anyways, let me check that. Okay, so here you can see this is already. So what I'm trying to do is right now. We have somewhere. Maybe I can find it. We had. Let me check if I can find like the old school. What is this? MIS data? No. Oh, really? So where is this? Oh, we made, I think we made even like the supercluster, we made even sketches how the bus is working. And what I had designed there, I will show you on KiCad. What I designed, let me check that. Is this the real life? Is that just fantasy? Okay, here we go. Yeah, so let's check it out. We have a bus system which is like here we have an open drain bus, which means we pull up all lines of the bus, and oh wait, is that the wrong one? Yeah, that's the wrong one. That's the Megacluster. Here we go. You fell in my trap. Here. Oh no, this is the cluster chunk. Where's the other one? Mini cluster, cluster blade, cluster. Oh, it's not open. No, it's 8-bit bus. Mini cluster. Oh shoot. Okay, let me open the project. Not mini cluster, it's super cluster base. Oh yeah, that's the project that I wanted to here. So this device here, it uses the supercluster. Let me show that. It uses the supercluster on top of here, and it has like a basic CPU in the center that's controlling the bus, or let's say the bus doesn't need a host usually. And you can see here are the pull-ups for the data bits 0 to 7. And then we have two different control lines, which are clock and command. Clock is basically the clock to indicate whenever a new byte is ready on the bus. So it's pulled low, then the sender sets the byte, and the listeners get ready to receive the byte, and then on the edge from low to high, the byte is valid. That where the receivers will read the byte from the bus, and so on. So that what was that. And what we did back then is we introduced command. Logic. Yeah, I don't have a logic analyzer. I have this Siglent scope. I don't have the digital probe for my key side, so I just pulled out. That's the only reason why I kept the Siglent. It's really cool for that. I mean, it's not that pricey, and with the digital probe I can do all sorts of digital stuff. But I assume like more than 8-bit, if you have like 16-bit logic analyzer, to have like the 8 bits plus command and clock would work here as well. And so what we used command for is to indicate this. Hey Kasper, hey Hannes, hey Max. Oh, and so many people. Wait. Hey Nick Borza. Hey, I missed people here. Okay, so comment indicates when a message starts on the bus. So whoever, like, if you read that comment is pulled low and you just wanted to send something and you read, oh, comment is pulled low, there is a message starting to be sent, and then you wait until the message is done. Yes, I am. No, I'm not complaining. The keysight is nice, but I don't have the digital probe and I can't afford it. Alright, so, and I still have like the Sigland one, which is good enough for my use cases. Anyways, we had the comments too, and we designed on live stream. I don't know if people remember, that was a year ago. We designed the whole, even implemented the whole bus system to work with the comment. Basically, the comment would indicate the start of the message, and we implemented everything a year ago. Now that is nice, and then we have like, okay, we want more than this supercluster here. We want the megacluster, which uses blades that are put on this megacluster base. So we have eight blades that are plugged in two superclusters to the blade base, and since these are clocked with 48 megahertz, and the 203s are clocked up to, I think, 144 megahertz or something like that. It's like 6 times the clock speed. We have a second bus in between. Do I have like a blade without a processor on? Where is my... Oh wait, here. There is the blade without anything on. So you see, we have one bus here, and that one is attached to the bus, and one separate bus here. So superclusters. Hey Javier. Oh wait, is this spam? So we have like a separate bus here and separate bus here. The superclusters can't communicate, but they can communicate over those two MCUs. Yes. No, it's not wooden and not silver. So it's silvery but not silver. Okay. So, but we have like a separate bus where all the MCUs from the blades are interconnected. So we have a second level of buses, like a second level bus that can be clocked 6 times as fast. So we don't have a bottleneck like when the data is trickling down to like the base here. So there is yet another one with USB and so on. But basically, this is the second bus, and it was designed to work the same way as that one here. Two buses. Okay. But there is something unfortunate that happened. We didn't have we probably didn't have Rota or Kaspar in a stream, so they were not able to spot the error while I was designing, or I wasn't designing it on stream. Do you notice something, except for this is rotated? Do you notice something on this bus? Whoever spots it wins a sticker the next time we meet live. Hey, the Shipu. So this is the bus. Do you notice something? No, they should be pulled high. Hey Johnny. No. No. Okay. I give you. Let's vote on that. What is wrong with this bus? What's wrong? Should be pulled down. D7 not connected. Okay. Here, now you can vote. Okay, there's the vote is on YouTube. Can I do? Now you noticed. Okay, that was an obvious vote. People are still insisting D7 isn't connected. It's all of them options. People are convinced. Okay, let's check that. Oh. Okay, so maybe that helps you a little bit. Yeah, I can end the vote. It was a meme vote anyways. You were right with your guesses. Comment is missing. I completely forgot comment, and there is no free pin to do that. And on the design, that was too obvious. And you see, these are the connectors. Yeah, these are the yeah, that's alright. So if you look here, we have like 2 times here the voltage and so on going on. Unfair quiz, yeah. No, but yeah, I mean that represents the whole bus, and there is nothing going on here. If you look at that, there is no CMD here to the connector. So, unfortunately, OCD. What broken pull-ups? There are no broken pull-ups. This is everything is alright. What's the broken pull-up? Loony cat? What is broken about the pull-ups? The pull-ups are alright. Hey Holden. Upside down. Okay, yeah, let's do that. Here? Now are you happy now? Should I rotate like that? Okay. Much better. I think the Australian viewers would disagree. And numbers are what? No. It's not 7-bit, it's 8-bit. You start at 0. Anyways, Space Cowboy, hello. Welcome to the chat. So yeah, unfortunately I missed that one. That don't matter. Okay, so how do we solve that? We don't have a comment. Sacrifice. Oh, you mean that? No, that's. Here we go. Let's zoom in. The revelation is already on screen. So you see, I use as trigger, I'm using comment here, and you can see what we had before. What we had before. Comment is redundant because the clock is not always clocking. Each of the processors has its own clock, and it basically listens to the clock. It can listen to the clock signal to determine is the bus busy or not. So basically, it doesn't need comment. It just checks. Okay, do we have like for a certain amount of internal clocks silence on the clock line, and then when we have the first clock pulled down, that's the start of the message. Super easy, and this is already the implementation of this bus. Done. Okay, we didn't test collisions yet, so hard claim on the video that I'm editing right now that it works. Listen, first principle. What is the first? What is first principle? Done, lol. Yes, ship it. Shippable. I don't care. If it works, it works. If it doesn't, it doesn't. Die Standuhr. Safety third. Shortest ever stream. Nah, not that easy. Okay, here we go. Oh, listen first principle, not listen first principle. First principle, electro engineer audiobook. No, it's not broken. So look at that beautiful thing here. We have people that say C coding is good enough. They will hate it because I implemented a template class that accepts that is so abstract that it accepts like set clock, get data, set data, whatever functions. And this is the whole implementation of processing on each like clock cycle, and it has like the three cases of the bus being idle, receiving mode, and sending mode. And there is like there is a to do. Can check data again. Yeah. Data. Oh yeah. So here, finished sending. Yeah, we are missing CRC. So currently, maybe I can explain this, or do I explain it? Yeah, let's do MS Paint. Or let me explain with code. People love code. Code review. We have a packet, and basically what we do right now is when we start sending the when we generate a packet, it basically has a source address, a target address. Hey Pixel. Oh no, Johnny, go deploying, or do it while listening to the stream. Okay, code review now. You will. Okay, so we have each processor has an ID. It's even like hard coded in the flash. That's not interchangeable. It's on this address in the Risc-Vs that I'm using. This is the address of the unique ID. It's 8 bytes, and you can even see them. Let me check. They are not displayed here, but I will show you. Oh no. Yeah, here. Unique ID. This is basically the unique ID of that one. And maybe we can even check it if that's okay. Let's read it. Okay, this is the unique ID of the one that we have currently connected and on the scope, and we can compare it if it's actually the one that we are sending. So we can use this as a source, and target is basically 0 is a broadcast. Yeah, that's basically like a MAC address. I don't know if it's like a MAC address per se, or it's an internal unique ID, like 8-byte unique ID. It doesn't say in the documentation. It might be similar to a MAC address. So it's but it's similar. It's developing like it could be a network protocol, because we have a source, which is the ID. And then we have the target. The target is basically the unique ID of the chip that we send the data to, or it's 0 if it's a broadcast. So all like a ping to all the receivers. Yes. So, and then we have basically the payload, and what we are missing right now is the checksum, and the checksum will be an XOR, which is like should be the fast to calculate there, because we don't have like not done yet. Let's explain the collisions again. That's with Paint. Okay, here we go. MS Paint. Yeah. Let me get that. So now we have like an idle. We have an idle CLK. And we have like let's say we have an internal clock that's for each of the CPUs is slightly different, and we process the bus on each like clock cycle internally. Like we have a callback that processes however that might be, and we basically what we do is we count like 1, 2, 3, and then say, okay, there was nothing happening on the clock line for 3 cycles, internal cycles. I'm using I think I'm using 4 or 6 to be sure, because you have aliasing, because the clocks might be shifted or something. So, however, you detect, okay, that's idle. So we can send data. So let's say this is data. So this processor will basically pull down the clock and put basically data is like it's random here, and then you set on that you set the byte, because that's 8 data lines. You set the byte. Let's call it B0, that's like the first byte of our data, which is also like the source address. And then we have the clock, and then this processor basically releases let me do it a little bit longer to the center, and then releases the clock again, which is then pulled high by the resistor, external resistor. And this is basically the time where all the other are reading this valid data here. So at this time, the the data lines should be settled. I can show you. So why do we need to wait here? We could also say, okay, we set the data just before, like one opcode just before we pull the clock low, and then we could double data rate, having like each down up can have like new byte. But here you go. Look what happens. Do you notice something? So this is if you use like 5.1K pull-ups, this is how your signal looks like. It's not a square like this one here. The digital abstracts basically the signal, but this is how your signal will look like. You either use like lower resistor values, so this is something that I would like to do, maybe to increase the clock speed here, but you have like a really like delay time for it to return to settle again. So you might like, even though like you change something on, let me switch the view again, change something here, you have some time for the clock to change, for the data to change. Hey, cosine. So this is where the data should be valid, and then we send the next byte and so forth. Okay, so let's send the next byte. Yeah, that's not possible. We have so many stuff going on there. B1. Yeah. We have, you know, I mean, we have the blades. We have this huge thing, and we have 4 layers, and it's not possible to make it better, I think, without a lot of hassle. So I will rather sacrifice it, because we have only like in this bus we have 9 pull-ups. I will change them from 5.1K to like 1K, which will be fast enough and not wasting a lot of current. So that will still be all right. The LEDs are worse than that. Anyways, what happens now? What is this? I pattern. Yes. Yeah. Nice. I pattern. Okay. So what happens? What happens if we have like 2 processors that want to send something on the data? They have like a let's say we have a blue one as well that was also count up. That's not the color. Or is this purple? I can say. Okay. Here. Boop, 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 boop. It's also counting and is waiting for their opportunity to send data, and it detected, oh wow, this is idle, I can send data. Oh, so basically what they do is also, oh wow, nice, we pull it down. So nothing changes for the clock signal. There might be a little bit like jitter here or something, but with our capacitance it's smoothed down. That's a bonus. But it will basically start clocking at a similar time, but sending different data. Okay, we have a different byte here. So we have byte 0 and then that and so forth. Boop, 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 boop. So now comes the smart thing, the ultra smart thing. We send like the first bytes here, so 8 bytes, that's reinventing the wheel. That's probably been there, done that. Probably like any other bus works this way. are different for each processor because we are sending the ID, the source ID. So we will detect, let me remove everything. We will detect we can detect if there is a difference, like this byte is not this byte, or maybe this byte is not this byte. But there will be certainly a difference in the first 8 bytes because we sent the unique ID. It can be that only one bit is different. SLA? Life inside SL, what is SLA? Oh, you mean that one? I don't know. Oh, that's like really early model. I think this is even a pre-release version of that. That wasn't released when I got it from Sigland. It works fine, I say. I'm not sure about it. I can't do a recommendation. I mean, it does the job, but I'm not. I have no comparison, to be sure. You can see, you can. I show you what we can see there. So let me further explain what's happening here, and let's check at the bits. Let's assume. So this doesn't get bigger. Wait, how do I change? How do I change the size? Ah, come on. Okay, let's jump at the bit. Here we go. Okay, oops. No. Yeah. So let's say we are looking at only at D0, and what the first processor sends is basically a 0, then a 1, then a 0, and then maybe a 1, and this one here pulls down or wants to do like, oh, it sends a 1 first, so this is where the data starts. Sends a 1 first, then it sends a 0, then it sends a 0 again. This is what it would look like. Okay. So what is the result of that? Oops. Yeah, it's open collector. Oh, open drain. Did I say open drain? No. Open collector. Yeah, OC, sorry. Open. Yeah, it's the same. Open collector and open drain, sorry. Yeah, we are in open collector mode. Oh, okay, so what is the result of that? We have same, different technology, yes. The TTL and CMOS, yeah. Oh no, Space Cowboy. See you next time, bye bye. Thanks for joining. So we have a pull up. Yeah, that's I think that's the tag. Here we go. We have a pull up, and that means it's whenever there is any pull down, the result actually will be a pull down. So the actual so the result will be So the result of that communication will be basically like that. This is the result. And so, but let me remove that part, because we have a collision detection implemented. How do I zoom in, zoom out? Okay. We have a collision detection implemented that does the following. You know, remember on the when the clock goes high, we have, come on, here we go. When the clock goes high, the data bits should be valid. So, while sending the data, so we let's say processor, the black processor is sending the data, it sets the data on this edge and then reads it back from the bus on the rising edge and compares if the bus has the state that it's expect it to be. So, processor, of course. So the black processor, so it would expect the bus to be low. Yeah, it would expect the bus to be low here and on D0, and it is low. So yeah, so this one says everything is all right, I'm still sending. The second bus, the second processor, but the change is more fast on the dropping edge. Is it? Yes, it is actually. Yeah, it is. But whatever, in whatever direction, that doesn't matter. You have like on this one here, you would expect the data bit to be high. However, oops, nope, it's there. It's there. It's not up there, it's down there. This is low, not high. That's wrong. So, what happens to this processor? It detects there is a collision. Uh-oh, nope. And cancels the communication here. Panic. So, this one cancels. Stonks slow. This is meme man on the stonks. And we have still the chance, since, yeah, police. So this one cancels because it detects the collision. And the funny part is, it will postpone the message to the next. Oh, wait, you can see the arrow. It will postpone the transmission to the next idle phase. But the funny part is, this black one has still the chance to complete its packet if there was no like collision in the different inverted way on any of the other data lines. So if we were lucky and D0 had either the same bits on the other data lines or a low bit there, the black one can still complete the transmission here. So that one might be lucky. I have no clue how I2C might be. Yeah, obvious. No, you don't need to. Let's check. Code. Let's check code. Okay, here we have get data, set data, are template functions which are implemented here. And this is how it looks like. We have a separate register for out driver and a separate register for in driver. And I hope we can verify that that works like that. Let me check. I might be wrong. No, this is not the right. this is another project. Let me check. Do they do that? No, that's also. Where is it? Where is it? Let me check if I can find the document. Oh. Boop, 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 boop. Where is this? I will just search it. Oh, you're right. You're right. Let me check. Data sheet, reference manual. Shit, where is it? Reference manual download. Okay, here we go. We download again. The third time. Here. This is our datasheet thing. So what did the router say? Yeah, we don't need to check that, but it's easier to implement just doing the check every single time. In the case there might be something broken on the bus. So either the bus is broken or whatever. So it doesn't pay. Hey, Elias M87. Elias RM. We'll call you Elias. Let's check at check the data sheet and see if we have rotor, whatever rotor says. Yeah. Do I? We can check how it actually is implemented. It might be there might be an input-output mode in that case. Yeah, mechanical. Oh no. Let me check. Collector. Ah, shit. Open drain. Nee, that was. Ah, come on. Every single GPIO. That's a bad. Here. I mean that. Okay. Look at that. You are wrong. Output data register, input data register. Separate registers, separate drivers. You see that? You are wrong, I am right. So that's why I would also assume that I think on Atmel it's different. So be careful if you're using Atmel or PIC, it might be different, and there is dual purpose of the register, but I'm not sure about that. I'm not 100% sure, probably not, but yeah, here we go. No, where do you see disconnect? Oh, Schmidt trigger on off. No, that's alternate analog inputs. Schmidt trigger. You can still Schmidt trigger and there should be connect input register other than alt. Okay, but in that case, if it was disconnected from the input register, then it will always fail because we don't have like an actual connection here. So I assume the Schmidt trigger is only for analog or whatever. What do you think? Yeah, that's shit trigger. That's why we have analog before that. Oh yeah. So okay. Yeah. It's high impedance anyway, like the input is high impedance, there is no Schmidt trigger. Okay, nice, okay. Okay, so Elias wrote on Twitch, to reduce the chance of a single node to monopolizing the bus, I would add a random extra number of away cycles before start. Here we go. Here we go. Let's look in the code. So I thought oh yeah. Yeah, I listened to the podcast. That was cool. That Dave subscribed to me, or at least he checked out my worst video from last year. Minus doesn't, yeah. Let's check my bus implementation, and then let's check here. Bus broken or collision. I thought of everything. Reset packet, data output delay, to do randomize, and then we use the unique ID of the IC as a seed in the beginning of the random number generator, and we just take like a random number of clock cycles, internal clock cycles, to delay it. And there will be, most probably, if we have like a faster, let's say, edge on the clock signal, so a lower resistor, because of the shift, like the slow shift of all the clocks on of the ICs, they won't like collide quite often, I assume. And then we have like a delay. We can decide how big the delay might be like 256 clocks in the end. But this is what I also thought about, just if both collide, so both packets would collide and we would restart on the next idle, would the same thing would happen again, and both would collide again and again and again. And this way we can assure that there is a randomization of the starting delay of the repeated signal. But in the first, like on the first try, we don't need to do that, or we do it automatically, just to be sure that if there is like an event that affects all the processors from the IOs or whatever, that it isn't pushed at the same time, because we have a ton of collisions and then we have a ton of try to avoid the repeating and so on. So we might want to put that send delay always on top of that. The fun part is we have automatic sorting of the IDs of the processor, because the low numbers always win. Like the pull downs dominate, so the lowest IDs would most probably be able to send first. And there is like some strange automatic sorting of the packets at the end, especially from the sources, which is really cool. Yeah, I don't know if it's desired, because that might be a monopolization of the bus system, but yeah, this random delay that should handle that. And this is how I explained it in my video, that is already like edited. This part is already on video and edited. Just explain with a sketch like that. Nice. This is the new bus system, and here is the implementation without the random thing. We can, let's shift. And look at that. We have even, let me get the camera closer. Oh yeah, that's me. Oops. Uh-oh, I disconnected the camera. Sorry. Where's power line? I need duct tape. Yes! Yes! Yes, I'm reinventing the one-wire bus. For more than one wire. Something must be broken. Fail counter. So I turned on the decoding of the digital bus, and we can see in hexadecimal. So you can see probably one wire and I2C works the same, but yeah, in I2C you have the host and clients. So and yeah. Okay, and yeah, danke. So let's check if that compares. Oh wait, digital bus, and we have system. Oh, nice! Congratulations. So we have like who asked for the digital probe. The Siglant is able like to decode unsigned decimal. So let's check. Let's check what data we are sending there. C5, C2H. Let's compare. Where is our C5, C2? What's next? 5A, BC. Let's check that. 5A, BC, CD, AB, CD, AB, EC to A, EC to A. Let's shift it. EC, there is EC. 2A. Yes! Yes, that's actually, let me make it smaller. That's actually the ID. So that sending works, but it's the only processor on the bus. So there is no collision. And this is basically a target, a dummy. I'm just sending low, high. And then, uh-oh. That sounded like my sound is broken. And then we have like some extra data there. So that was low, high. And then here's some extra data. What is this? What's this extra data? Can someone decode that for me? 62H. What is this? 62H, 69, 74, 6C, 75, 6E, 69, and there is a 0 at the end. What can this be? Is this ASCII code? What? bitluni. What? Do I have a typo there? Nice. Yeah. You almost trolled me. Yeah, no, that's actually what I'm sending. So you can see here in the main, yeah, small letters. That's the text that's sent over bus, and this is how it works. Look at that. This is the main loop. It just spams the bus. It's implemented that easy. You just create a packet. You have the unique ID here. The data length, which is bitluni plus the terminating 0. The text, that's the data, that's the target, which is a dummy. That's the packet. I'm not sure if I will keep the packet structure, because we can maybe come up with something that's easier to work with if we want to receive more packets. British, what? British in it. In it. Boss in it. Oh, Dan is also here. I didn't notice. Dan, I just promoted your channel at the beginning of the stream because people were asking about the ASIC, and there is like half an hour monologue in your latest podcast. When is it released? When is it going live? I mean, the supporters can get it right now on Patreon already. It's ready to listen on Patreon. And it will be released at some point in future. I have to go work on the Volvo. It's approved. Oh, nice. Yeah. Oh wait, it's approved. Of course. I don't. Oh no, you waited for my approval. Of course it's approved. I don't really mind anything. I didn't say anything that is not approvable there. Oh no. Did I miss the question for that? I thought you were just finished. Yeah, we approve. Oh wait. Okay. Okay. Hey Taran. Everything approved. It's like, I mean, put it live to your supporters. No, that's your thing. That is your thing, and people should support you as well. I can listen to it already because I think I'm still a supporter. Oh no. Yeah, I'm bad at responding to messages and emails. Always. Wi-Fi password. Yeah. Okay. You know what? I wouldn't be. Let me tell my philosophy. I was really anxious, like a few years ago, I was anxious about what I show, what I say on my channels and whatever. But now it's 10.5 years that I'm doing this stuff on YouTube, and I'm still a teeny tiny YouTuber compared to what's out there. So actually, if you compare it, nobody actually watches my stuff. Like, I mean, not nobody, you are not nobody, but there is only like a small fraction of people that are highly interested in that topics, and they don't mind about whatever I might say wrong or what. I just don't care. I just gave up. I'm mentally dead. Emotionally and mentally dead inside. Elite nerds, yeah. It's the Ford Volvo, sadly. That's backstab. Because I drive a Ford as well. Oh, yeah, my first car was also a Ford Fiesta. And that was janky. I mean, the suspension was completely worn off. it would bend over in the curve like outwards. I feel like I like that kind of feels natural. Yeah. Natural except when I do advertisement for Huawei or something, and now we have something like there are German right-wing politicians that are candidating for EU Parliament, where there was like some spy caught in his team, and he was basically doing trips to China, invited by Huawei, and there is like some controversy about, like, he declared that the flight and the hotels were paid by Huawei, but he claimed something different on a show. It's highly political, but it reminded me of me because I did also videos for Huawei, and now I feel like this. I don't know. Yeah, I'm an agent. Of course, I'm an agent. I get paid by Chinese companies. No. Here everything is independent on the live channels. There are no product placements except for AliExpress affiliate links and Sigland. Now this stream is sponsored by Sigland. Here we go. Anyways, yeah, we have I'm sweating. Okay, so what I wanted to say, I don't care much about my mistakes that are Sigluni. Back to our stuff here. So the bus is pretty easy to work with if it works. I don't know actually. So what's happening here basically is usually the send would copy the packet into the buffer because the bus has a data in data out buffer, but I don't like that design really that much because it would like block or not block, so you get a false if it wasn't able to send the packet, or it waits for data out ready to be false and then copy the buffer and be done. Let's make it standard. Looney Bus. Oh, okay. Nice. Johnny is supporting everywhere. Yeah, Johnny is in for a good treat. The podcast was sponsored by Johnny Bagdal in some way. At least Johnny is appraised by me for donating the Home Assistant Yellow to me. and there is a rant about YAML and spaces versus tabs. So very highly controversial coder politics going on there on the podcast. Oh no. All day long, yeah. Avra, hello. What was the message? Okay, what we need now is several things. YAML, please not. Is there a Commodore Atari wall? I think like joining late. Oh yeah, I just explained the bus system for my Megacluster that works with a ton of Risc-V CPUs, and there was a huge mistake. A short recap for people who are joining. a short mistake, a small mistake where I forgot the command line to put on the second bus, and now I needed to like implement a different way of detecting an idle bus and handling it like that and detecting the start of a message. What we need to do right now is to check for there is one more thing that I didn't mention. So what happens in the case if we have what is going on here? What's happening in the case we have a collision on both lines? So both processors with wrong color. Both processors will detect a collision okay, let me do it like that. If both detect a collision and there is a receiver listening to that, so this receiver will listen to that. Let me draw an ear. How do I draw an ear? How do you draw an ear? Let me draw an ear. We need the sheeple to draw. Well, how is that? Wait, let me check. There is this thing. They collide with each other. So it's listening to that. And how does, so those two processors know, oh, my data should be that, but it's that. Yeah, but that's yeah. So the issue is those two processors know what the actual data would be, but oh, Charles, yeah, he is on a higher level. We are doing low level here. I mean, no, yeah, he is doing lower level but higher sophisticated stuff. So not through a resistor. We are just monitoring for collision because we have this open collector, open drain bus, and they can talk at the same time but read back the data just like a half clock cycle later and compare the data to what they wanted to send. If it's a mismatch, they will cancel the transmission. But only those two know what the actual data should have been here, and the listener doesn't know. The listener is clueless if there was a collision or not. And therefore, my friends, we do the following. If there is a transmission, let's remove that. Oh no. Yeah, that's basically what we are doing. Yeah, we are reinventing the bus. Okay, here we go. And this is, even if we send like 1 byte, whatever, we could like the IDs and everything, that is already a layer above. If you just consider, if you think about all that, we have this hardware layer here, and then we have like this software layer of transmission and collision detection. The collision detection is independent of the unique ID that we are sending at the beginning. That is already some sort of a higher layer protocol. So the actual bus could also send like only a single byte, and this byte could be whatever we sent there, and there could be already a collision there. So what we need to do is to put a layer in between that checks a checksum. So we have a checksum, and I would suggest to make it an XOR, which is basically XORing all the bytes here. So if this is like FF, then this will be as also an FF, because this is the XOR. And then if you you can do, or let's say, no, one talker would not certainly complete the message. It compromises the data. I will show you an example. So let's say, yeah, so we have 0F. Shit. Okay, and this is basically, that XOR can be, the checksum will be, for simplicity, calculated on the fly, and the receiver, the listener, can do basically the same. It knows when the transmission starts, because basically an idle bus is cancelled here with a low clock, and then it reads all the bytes into a buffer and does an XOR on the fly of each of the bytes. 8 bits is the bus wide, and then on the last byte we just take the checksum. CD no, too sophisticated. Error correction. So we just XOR the last byte, and it should be 0. Oh. No, one might not reach the end, and I will show you the example. So if we XOR all the bytes, including the checksum, this will result in a 0, and then we have a correct transmission. Okay, now I show you an example. So we can show the example. No, it's two lines, unfortunately. Oh no, we can do. Yeah, we can do that. Okay, so we have, let's say, we have four data lines. All the data lines will end up 0 in this case, because we have 0 here, we have 0 here. Okay, wait. Yeah, if it's only a serial bus, it would work. But the multiple lines, you can basically, one tries to send that way, the other this way, and then you basically flip it. Yeah, whatever. You know what I mean. Okay. Okay, here, I draw it again. So this is the first pair, let's say D0, D1, no, wait, D0, and then we have this and that, and this and that, and this will be then D1, here. Now you basically, this one loses here and this one loses here. So both lose on the first, basically on the first byte, both transmitters lose here. So there's an exclusion. And you can also, we have 256 CPUs, but there are on a concurrent bus, there are only 17, up to 17 processors. So there can be multiple processors. So what will most likely happen, all lines will go low. Yeah. This is what happens. So data is parallel, and that's so, but we solved all that, and we just need to implement now. Hey Rita. Space Cowboy, Manhattan. There, I grew up in Manhattan. What was this? Why fight over bus at all? Why not sequential? Because parallel is faster. Welche Stadtteil? Frankfurter Berg, Fechenheim und dann Bad Vilbel. Bad Vilbel ist nicht mehr Frankfurt. Not that great city parts of Frankfurt. That's why I didn't like Frankfurt very much. But what you can do if you're a migrant? You use one edge for the bus master assertion. How do you Berlin Pankow? Not Pankov. How do you fight over the bus? How would you, if you have a serial bus, how would you do it? I'm wondering. Ja, nein. War besser als Bonames, aber nicht viel. Nur Asos da, ehrlich gesagt. Aber Fechenheim war schön. Natur, aber Kassela ist Katastrophe gewesen. Okay, so you have a bus master, that was the command line. And what happens there? How do you fight? How do you fight? Let's say you have the bus master, this is the master. So how do you fight over this line? One pulse low, and then what happened next? I'm just curious. How does that work? How do you fight over a bus? Ja, die Nidda ist geil dort. Das stimmt. Also wenn man da einfach so ein bisschen Richtung Berkesheim weiterzieht, da gibt es ja so Schrebergärten und Reitplätze und sowas, und dann die renaturierte Nidda ist schon ganz nett. Deswegen sind wir auch weiter nach Bad Vilbel gezogen. So. How do you check that? I mean, how does that happen? I mean, look at our, let's say, you have it's pulled down like that, and another one joins. Okay, yeah, probably is. I mean, it's an obvious. You see, I'm reinventing the wheel, but there is only so much you can do with those tools, and if it's there is like only one obvious solution that is good. Creepy, ja. Ja, Frankfurt war noch nie so mein Fall. Ein bisschen zu... Bankfurt war mir ein bisschen zu versnobbt. Ich habe in Darmstadt sehr lange gelebt. Darmstadt war... also ist immer noch meine Lieblingsstadt. Bis auf Berlin. Berlin ist... So, what I'm talking about... Frankfurt was not so my city. I love Darmstadt, where I went for university. And Berlin, I love Berlin, but okay. On one line you can send ID bit by bit, then you fight conception will work. Oh, you're right. Yeah, that can work. Can that fail? Okay, so Chris, that will probably fail because we don't have like exact edges here. We have all the clocks working slightly different times, and there is no like flip-flop. We would have like how many cascading flip-flops do we need to negotiate that with 17 CPUs? And also we don't have like a really, that's like an analog edge, and if let's say someone pulls the edge low and then we didn't reach the threshold for low, so someone reads at this time and sees, oh yeah, it's still high, and then it joins pulling it still low and thinks, oh yeah, well, it's all right. I mean, what I could do is basically Speckgürtel Bock auf Menschen hat, die in die Stadt rein. Ja, im Speckgürtel kenne ich mich nicht so gut aus. Ich war immer nur Dave Darko. I'm visiting Dave Darko in Berlin. We're talking a little bit on Twitch about how cool Berlin is. Berlin is like, someone compared it, there is Germany and there is Berlin. So like Berlin is a different country because also it's a cultural melting pot, and I love it. You can get like, if you love culture or like this progressive culture, then Berlin is the city for you. And there, basically everyone speaks English there at the end because it's so mixed, and you meet so many cool people. But if you don't like many people, then probably Berlin is not for you. But I really like Berlin. Visiting at least once a year. Yeah. Element 14 Darko, yes. Yeah, what we could do is the negotiation of like we did with our serial ID, but then the lowest one will always win. So there will be, you need still to have like this delay thingy. And the ones with the highest ID or whatever with the highest ID will be pushed back till the end of the queue, and it can be that they will never get their turn. And this way, if we're using a parallel bus, we can utilize, like we can send way more data way faster. So this transmission, even like with this slow clock that I'm using right now, we can check on that. Let's see. We have, let me measure. Yeah. how do I add the measure? TDMA. What is TDMA? What is TDMA? Look at this. In this time division multiple access. I have no clue what that means. You have to explain. So in this short amount of time, we're transmitting 16 bytes of IDs and 8 bytes of text. So this is 24 bytes. Ja, Darmstadt ist sehr entspannt. Oh, thank you, Kaspar, for donating a sub. I want to see the supercluster calculating the first 1000 digits of pi, prime number, Mandelbrot set, something like that. Run a counter clock. Oh, yeah, okay. Yeah. Hey, Oleg. Yeah, so that's a good idea, but then we have to like it feels like the time slice thingy might be something that's but you have like to identify. You have to identify. Oh, so much TTS on my ear. I wait. I wait until my ear is free so I can talk. Okay, so the issue is that like the time slot thingy, that feels like it's a different layer of the protocol. So when we start, we have like an 8-byte ID. We can't like assign. We don't know how many CPUs are on this whole bus system, and we would have like to assign to each 8-byte address a single time slot and cycle through all the 8-byte addresses. You know how much that is? Okay, danke Space. No, it's 8-byte address. We have a unique 8-byte address. So, Chris, what we can do is we can use this system, like my parallel bus, to basically knock on the door of the host that catches all the IDs. Yeah, generate random solution. No. Yeah. So what we do is we have like a main CPU. In that case, is the one on the blade that will collect all the IDs of all the CPUs, and then it can assign each of the CPUs their own time slot. Let's say a 9-bit address or something. And then this 9-bit address, you can basically poll that. There can be. We don't need to use it as a master, but we can use it as a master because that's like, let me show that. We can basically assign that one that has USB on that. Like the high bus is basically connected to this one. So there are 17 CPUs on this bus, and on this bus here, like this is also. This is basically the same thing. So each blade has two of those. These are connected to this bus, and these here have a separate bus that's connected to this one here. So that's basically that one is the interface zwischen between the buses here. So this one is connected to both buses. Here we go. Okay, so we can have a master, and that's what I actually want to do is zoom, focus. Token, yeah. But that can be implemented on top of this bus that initially somehow manages to, like, if everyone starts at the beginning, they all basically say, hello, I'm here. This is the first thing that every single processor will do, is sending a broadcast packet with their ID. So what we will have, yeah, handshake. That's what it's called. So basically, handshake would look like packet handshake, and then we have basically the unique ID of the CPU. Then we have 0 data, 0 address of the data, and a broadcast. And this is basically the handshake. And this is trickling down all the buses. Three-way handshake. This is trickling. I think I will collect it even on this one or individually on the buses. But it would be cool that this one knows each of the small CPUs as well. So I'm not sure about that, but basically what we can do is we collect all those packets, so all those packets in this CPU and store the unique IDs, and then assign work packets to those CPUs if you want to process data, calculate pi or whatever. So that one will be basically the master. No, we don't call it the master anymore. We call it the host. This will be the host. The ones on the blades. The ones on the blades will be basically like a switch or a router, passing down and up the packets. Coordinator, yeah. XOR, kein Mauszeiger, also XOR. Animation versus physics, Alan Becker. I don't know. Can you can, I don't know if you can send. It ain't a host. It's acting as a. Ich weiß nicht. Kannst du einen Link oder sowas? All right. So yeah, I don't need to. Let's comment that. So let's implement something. Now I did a lot of texting. Yeah, let me somehow I think the LED is confusing the camera. Hierarchical, and this is rather a cooperative system because okay, let's do an XOR then. Should we calculate it in the packet? In the packet will be the easiest. So basically what we do is packet and then we will do checksum. Yeah. Checksum, and then we will basically check some. Here we go. Yeah. I will watch it later, I think. Or let's watch it here. Maybe I can watch it. Let's check. Now you could have. Oh, potential energy. Nice stick figures. You know the old Kung Fu stick figures? Animation versus physics. Yeah. That's the fighting stick figures. The Kung Fu ones. From 20 years ago. Oh, nice. Gravity well. Cool. Yeah, looks cool. I will check it out later. Thanks. What is the proper way? I have no clue. To be honest, I have no clue. That and basically 8, and we will add it like that. Buffer 16. Yeah, well. 16 plus size equals checksum. Okay, I think this is correct. Yes. Okay, so this is sending now the checksum as well. Should we compile it and just test it and see if we get like a checksum? Let me compile it to see if we broken everything. Okay. Okay, it compiled. I will upload it here. Boop. That's it. That is a checksum. That is a checksum. Here we go. Oops. Oops. Okay, so wait a second. This is oh yeah, we need to change size as well. Shit. Sorry. Size, that's missing. No. They will not. They're just pulled high. They're always either low or high. None, yeah, checksum is not because we didn't increase size here, so we need size plus 1. So we would do the following: data out size plus 1 plus checksum here. That was missing. Okay. Compile that and switch, so you will be live, looking at it live. And we should have a 0 and Here we go. Oh, interesting. We are not clearing the bus after we set it high at the end. So the only thing, like when the clock goes high, the data is don't care. Nice. Okay, interesting. So checksum is 200, and we could, how do we verify that? We can do, while doing it like that, let's display it in binary. So we could count the ones and zeros of each of the thing. So the only thing, the third position should be an odd number of ones. Yeah, I don't count that. You can, nah, I don't do that. It's too much. You can if you like. I assume it's alright. We can do like the checking for the collision. Should we do it on the fly? If the packet is, yeah, we can implement it here. Oh wait, you don't see anything. We no. So what we will do is we can either check the checksum here or not do it. We can do it in the higher level at the end. So when the packet is ready, check data. That's output. Wait, this is right. Send. No change in the high state. Receive timeout. So we have, like, when we are in the receiving state, we need to detect when the packet is over, and the receive timeout needs to be shorter than the send timeout, so we don't like connect two packets that don't belong to each other. That's why receive timeout, and then we have data in ready true, and what we can do is check checksum. Check checksum. That should be basically 0. If checksum 0, then ready is true. Oh, and state is idle. Data in size, else. Usually we wouldn't need that data in index because it's reset anyways in the beginning, but I will do it. That's actually not needed. Didn't check out. Didn't check out. Checksum. Okay, checksum. We need it here. Checksum. It should be only 1 byte, but we have a 32-bit processor. It's faster and easier to work with integers. Checksum, checksum, checksum. So state is receive. Oops. New transmission. Check sum equals 0. And then we have set data Oh, that's send. No, wait, that's sending. That's receiving here. D, and then we have checksum XOR D. That's receive. Yeah, it's a bit early. Blockchain, yeah, checksum. Meme CPU, and I think this is it. This should be it. This is the only get data here. No, there is also send get data, but this is all right. We check it. There is no need to check on this side. Yeah, that's all we need. I think this is it. This is it. Now we need conquering CPU that's doing the same, but a little bit different. So we are now 2 hours in already, only explaining stuff and implementing the checksum. Put after transmit. Yeah. Okay, so it does that one sends FF here, data out. Set clock 1. The problem here is that we set to idle on rising edge, and we can't do it yet. Wait. What? Yeah. Yeah. This is only by only when the collider here. You mean that one? The rolling pin. Yeah, but only in that case. So previous clock out is 0, and then we have, if clock is not, then we have some other sort of collision. This is when the collision happens on the clock line, which is also covered here in some rare case. Otherwise, check data. To do can check data again. That was... What case is that? I know that... Wait. Data. Oh yeah. This is 0. And we could check it there again on the rising edge. But the rising edge... Wait, no. Let me check. Previous clock... That's alright. Previous was lower. Clock. Oops, collision is messing with the clock. Now I need to check where I am right now. data out index is else. Oh yeah, that's a new, either a new byte. Oh, you're right. We can set it here to, basically this is already like 1 clock after 1, so we can set FF here and this will be correct. So we can release the bus here. Finish sending. Let's do that and check it out. Yeah. Let's check it. That's basically what's happening here. So we have the rising edge. There is, we can see here is the rising edge and the data is valid half a clock. Thank you for that. That was a good tip. And the bus is released. Sweet. Success counter, yeah. Now we have to create a, we need to create we have some to-dos to do. We have some to-dos. It's basically this randomizing here, randomization. No keys. Oh, 8051. Oh, I'm so sorry for you. $8051 is difficult to work with. I don't know. It was strange. I used it once, but it's good. Teaches you the basics. Okay. Everyone loves. Okay. Control. Forgot about. Yeah. All right. We need randomization. How do we? Where do we get random number generator? Random nightmare fuel. Okay, I need like a random number generator that's easy to calculate because we don't have many clocks. Okay, let's check Wikipedia. Where's my C code? Oh no. So pseudo number yeah, but I don't think I want to use the C++. Exponential. Yeah. Oh yeah, you're right. We did this before. We did this before. We asked ChatGPT already. Ah. Quantum what? Oh no! What is this? What? Ultra long. Is this an ultra long? What is this? No, 64-bit. Yeah, we did this, but I can't find it. If you find the link. Next, seed, state, seed. Yeah, okay. Okay, that looks alright. We will trust it. X or shift. X or shift. Oh wait, that is this X or shift? That is X or shift. What? That's X or shift. That's the same code. But what you need like to add, because if you have 0, it will always stay 0. It will always stay 0. So if the seed 0 will never change, seed 0 basically output 0. Oh yeah. Okay. All right. Yeah. I will just use the initial seed. Yeah. Okay. Yeah, I will use the UID for the seed. That was my initial intent. Let's do that. So let's put a random noise source. Yeah. Wait. I did wrong. Seed. There is already, I skipped already one step here. That's X. Okay. All right. Seed R&D. Or let's say R&D seed. Yeah, let's do that. Last R&D and then void. Good night, Max. Seed. Ah. Wait. Nope. Let's do that, and that's the S. Okay, pseudo random. Like that. Here we go. And what we do is maybe we should do the UID here. This UID and then we do seed UID 32 and then XOR UID. Okay, so what we are doing here, we have a 64-bit UID and we basically take the upper 32 bits and the lower 32 bits and munch them together with XOR. So we have still most probably a unique ID. Oh, nice. Arthur. Yeah, I'm watching, currently what I'm watching is Star Trek Discovery, and I was really disappointed about the first episode. I'm already, I think I'm watching currently the 4th episode. Not finished yet, so no spoilers, please. Who doesn't want to be spoiled about the first episode of season 5 Star Trek Discovery? Fly out shrooms, yeah. Who wants to be? I can rant on that one. We do here checksum, and then we have randomize R&D and 255. Okay, so the most clocks that we will wait is 255. What do you say? Is this alright? Yeah. So actually, we could be right. Good enough. Yeah, I would say. Looks. Yeah, it doesn't like. Oh yeah, init. You no matching. We need to do the UID thing here and the init bus init. Basically here. So what we could do now is we can let the bus handle the UID. Yeah, seed X. What is? Oh no. Yeah. We change that. Okay, that works. Now let's upload it. Sanity check. Shouldn't, yeah, didn't change anything. So fast! It's uploaded and working already. Okay, here we go. We should be able to, you know what? We will only send handshake. We will only send handshake, and we will upload this to both concurring handshake. Here we go. Boom. So no more bitluni. Let's check. All right. Isle of Scotch, hello, long time no see. Couldn't pay me enough to watch STD again. Star Trek Discovery. Yeah. Okay, so here is the rant. Spoilers ahead. You can mute me. I will wave when the spoilers are over. Okay. When spoilers start, I will. Okay, no, might be spoiling. I will wave if the spoilers are over. So. Episode 1, Season 5 of Star Trek Discovery. They are chasing two rogues that have stolen an artifact, or I can say it's what's an old manuscript or book or whatever. And they are running away from the whole Discovery crew with Michael and the crew of another ship. So we have two ships with very experienced captains, and this other rogue dude, the boyfriend, the wannabe boyfriend from Michael. Those three are chasing the rogues on some sand bikes, like on Star Wars. It reminded me of those races in Star Wars. And they are chasing the two on this hover bikes, those two other rogues that have stolen the artifact. And the two ships, like huge Starfleet ships, are in orbit and waiting for whatever. And the two rogues are escaping, and they have hidden. Wait. They have hidden their ship somewhere in the desert. And then Michael discovers, oh, there is a signature or something of this stupid ship from the rogues. And they are then, what happens is, instead of Michael, okay, I tell you what the writer thought it would be a great idea to do. They say, oh, and there is like a wall. Oh no, no, I'm still spoiling, sorry. So the ship is somewhere hidden in front of some caves, like a canyon and some caves, and there is... no, not waving hands. And there is a mine attached to an entrance of the cave. And Michael discovers, oh well, they want to escape through a cave. So they want to explode like the entrance of the cave. So what happens is they start discussing, while chasing the rogues, start discussing what to do. If they want like to destroy the mine for the entrance of the cave, so the rogues couldn't escape through the cave, but that has the risk to cause an avalanche of dirt and that will like endanger the village. That chance is 30%. Or they let them escape through the caves and try to chase them when they leave the cave again. So there's like this dispute. They're discussing the situation while chasing the rogues. They're discussing the situation. Do we let them escape through the cave? So the rogues... Yeah, maybe. So what happens is they see only the two options. They let the rogues detonate the mine for the entrance of the cave and let them escape, or they shoot the mine and cause the explosion, which will also create an avalanche. And there is only those two options that they see, but they have two starships in orbit and they have personal transporters. This is like 1000 years in future. They have photon torpedoes, they have everything. Instead of shooting the ship of the rogues before they arrive there, from the two spaceships, one of the ships can teleport with spore drive. It could basically teleport on top of the other ship, so the rogues couldn't enter. And there is like the first commander is waiting just for Michael to say anything or what they decide on, and they're arguing what to do or not to do. And the only thing that they come up with, oh, we shoot the mine and risk 30%, take the risk, endanger like the population there. So, but they have also the other ship who has a tractor beam. And I'm asking myself, they have personal transporters, they have tractor beams. They can take the mine and transport it into space and let it explode there without endangering anything. And the rogues couldn't escape, and then they can attack the rogues. What? This is like the stupidest decisions ever made. Lazy writing. That's lazy writing. That destroyed this whole episode for me. What? Not only for humans. They can teleport anything. They can teleport utilities. They can use a phaser. They could attack the ship that was sitting there and waiting for the rogues to arrive. They didn't discuss there is like a shield. We can do whatever. Nothing was mentioned there. So what happened is, they shoot the mine, and then the rogues arrive at the ship and try to escape because the mine didn't cause the avalanche. But then the rogues see, oh, we can cause the avalanche and shoot the wall again, and then the avalanche is caused. And the only solution they see, no, we don't use a tractor beam or whatever to stop the avalanche. We put the two ships with the shields in front of the avalanche to protect the village. And then basically, oh yeah, and we let them escape. So, later on, the ship was damaged and we needed to go to the dock and repair the ships before we can chase the rogues again. But the ship wasn't as broken. They could still like fly to the dock. In any other case, they were so endangered, the ship was half broken, whatever, they still chased like the villain until the end of the universe, teleported everywhere, but they were not able to chase this ship there. One thing before that, they let them escape already once because they had like a decoy device. So you have like the Star Trek, it's Star Trek Discovery Season 5 Episode 1 Lazy Writing, which was terrible. So they had, before that, still spoilers, sorry, before that they let them escape once, which was not lazy writing, because the rogues used like a decoy device, they just spawned drones that created different warp signatures, so they could escape. But this time, there were no decoy devices displayed. Like you couldn't see they used that again or whatever. They just escaped. They could have only one warp signature this time, and they could basically chase it. They could teleport there and capture the ship. They have 2 starships, Starfleet starships, with the best commanders imaginable, but still, yeah. Oh well, and they don't have ChatGPT that is smarter than those stupid captains arguing on some like hover bikes. Okay, so rant over. I'm waving. No more spoilers. Kirk and Picard. Yeah, Picard would be way smarter, and even Janeway would be smarter than that. Or 7 of 9 would solve that issue like within 1 second without arguing. Okay, next show. Yeah, the episodes after that are alright. It's a like nice story that builds up on a former TNG episode that I need to look up. Outpost? Azuken, I don't know that one. Lost lol best commanders. Yeah. Scott, you agree with me that yeah, poor decisions or lazy writing. I would say, I mean, it's very adventurous. Like Star Trek Discovery is very adventurous, and it's a new modern style of Star Trek. Compared to that, like Star Trek Picard, like the last season, was really excellent. Like I want to see that. Come on. Könntest du mich anflüstern? What? Könntest du mir was anflüstern? Kann ich dir ab und zu auch was Schönes senden? Sorry, Rita, ich weiß nicht, was du machst. Crocodile Dundee. Yeah, season 3 of Picard was excellent. Yes, I hope they pick up on 7 of 9 as a captain. Okay. So we have the random number generator, and now next problem. Next problem, peeps. Oh, yes, Scotch. Thank you very much for the donation. I almost missed that. Worst writers ever. Yeah. I have to agree that they make like really poor choices. I always call it lazy writing. Quite often in sci-fi, you see either the writers have no good advisors, or they pick a choice against the technical advisors, or they don't have like technical background and no advisors, which is like or like lazy writing, no research whatsoever, and basically because that fits the story, we just go ahead and assume like, okay, we will upset maybe 30% of the viewers, and the other 70% will be fine with our decisions. Yeah, but that doesn't make like excellent shows and movies. EEV blog unboxing Witz. Ja. We are only like few people yet, and everything is civil, so usually people should be able to send links. I don't know if you, yeah, someone Z80 can give you rights to send if you. Oh yeah, Witcher. I didn't finish the series. Witcher was unfortunately. You can write it. Yeah, Rita wanted to send a link or something. Oh, okay. Okay, then. Yeah, I'm confused. I'm not familiar with Twitch. Anyways, let's continue with the Megacluster fiasco. Now my voice is gone. I had really like a sore throat. Not only sore, my throat was inflamed the past 2 weeks. Back to work. Yeah, we want to see collisions. Um, Whisper. Okay, let's do an ASMR. We can do an ASMR now. What is this? This is the wrong thing here. No, what we wanted to see. Oh no, my voice is. I destroyed it. Megacluster blade. This is what we want to take a look at, because we have different pin configurations, my friends. We have connector to the base, which we just programmed. Bus lines. Okay, thank you, the 80. There is the clock. The clock goes in here, and then we have clock 0, and this is the clock 0. That might not have been the most wise decision to do, to put the clock on PD0. So now we need to try program the blade and do exactly the same thing. We have a different code base for the blade. And I hope, oh, yeah, we can debug it. We don't need that anymore. So this is nice and dandy, the main, and we can basically cluster, supercluster. We're oh yeah, by the way, I installed or updated my IDE 2.0, so you're not upset anymore. Um, 1.8, yeah. Okay, so this is the version. This is the second main. It differs slightly because we have different pin configurations, but we might want to copy everything except for, so like this part, we just keep the pin configurations of I think that it works great. The second version of the Arduino, is it? It might be even the third version now. It works alright, except Yeah, still no tabs or spaces. Maybe there are. Let's check. It's a mess. My code is a mess because of that. Let me see. Um, um, no tab spaces here. Preferences, maybe tools. No. Oh, stupid. It's faster with compilation, I think. Something like, oh yeah, one thing that improved in this version, the serial monitor. Mwah, excellent. It automatically reconnects and stuff like that. That didn't work with like the version 1. Oh yeah, we have to change the clock, which is basically now... Oh, we don't have bus here yet. We need to copy the bus implementation. Here, cluster blade. Boop! As easy as that. Bus implementation, and then we need to check for clock. That was D0. Yeah. So GPIO D0. It might. It's always at the same time for whatever reason. D0. Oh! Oh wow, I didn't notice. Look at that. The quotes are displayed now in the new chat. That's cool. I didn't know. Now our quote generator pretentious quote generator. Oh yes, that's cool. I love it. I love it because we were not able to see that before. Okay, that's the clock. The data lines should be... Oh, what are our data lines? It works. Christian. Bus. Which one is it? Shit. Okay. Bus. Ah! Bus 0. PA. Oh, that's still PA. Nice. And that's 0. Nice. And the other is PB. So we have PA without any shifts. So we have PA. We should also update the comments. Full of copy paste bugs. And no shift here. Boop, boop, boop. Like that. And like that. That will be optimized away anyways. So A, D. include bus. Yeah, I have chocolate. Mukbang. Sweets don't count. Sorry, I had dinner already. Space Cowboy. I always have the cheapest milk chocolate on stock. Oh, the Beast. The Beast obviously is my the Beast and the scientist. The beep, 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 beep. Scientist. Animal, yeah. The one that plays the drums. That's my favorite one. Beaker, yeah. Beep, 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 beep. And of course the two old guys that are always like cynically commenting everything. Now I need. Where's my grumpy twin? Yeah. Smørrebrød. Oh, the cook. Waldorf and Stadler, yeah. So what are your favorites? I want the favorites of all of you. The Swedish chef. Oh, is he Swedish? I didn't know. I mean, I was a kid. I didn't understand stuff like that when I watched him. The Swedish? Really? Is he so iconic? Chicken in the basket. We will check them out. Before I forget what I was doing here. 0, we have checked that. Reset bank. Wait. This is not our reset. Yeah, we don't do this here. This is reset bank. Smørrebrød. Okay, so we have we need to update that, and we will check out the Swedish cook, and then we have 0. Yeah, we need Johnny, but he's deploying right now. Some customer wanted to get something deployed. That was our stuff, and then we have the clock, which will never work in our whole life, because that doesn't work like that. Hello, Skidiki Popop. Skidiki Popop. Yeah, probably. Oh, he was done already. Okay, yeah. Then I know what you meant. Okay. Yeah, you know what? I had a bug before where I didn't set the clock to high initially, and so the bus was never idle, and it didn't work, and I was wondering what is happening here. Oh, surströmming. That's the pukable experience. I never smelled it. One of my... What happened here? Huh? A colleague of mine tried it once. Yeah. I think to initialize that, we need to change that, but we can try. Oops, what is that? Oh, time. We didn't specify time. What is... Where is it defined again? Oh, yeah. Huh. I don't know if we have like... Where would be the right place to... Okay, we check this processor first. It will not work. And then, because we need to initialize D correctly, so I will download that. Yeah, okay, that worked. And now I will switch again and leave the other one idling all the time. Oh, what? There is safety restrictions for air transport of that herring. Nice. Yeah, it's bioweapon. It should have like biohazard sign. So it should be handled like that, because imagine like you can basically, if you throw this herring into the cockpit of an airplane, that could be a dangerous situation. In Germany, letting someone puke is already a felony. Stinkt wie Verwesung. I never tried. So is it really like a rotten smell? But did you try, Rita? Did you try eating it? Blade base. I will switch to that one. And I will let that one idle here. So uh-oh. That was wrong. That was wrong. Okay. 48 geboren. Okay, Rita, hast du schon mal den Hering probiert? Hast du ihn wirklich mal gegessen oder nur jetzt Stories gesehen? Yeah, I'm not really into that kind of stuff actually. Okay, how do we even check if there is a clock here with that device? I uploaded it. Oh wait, that's the. Oh no, I uploaded the wrong stuff here. I need to upload that one. Yeah, I would pass that, but I don't mind really smelly things. Like cheese. I eat any kind of smelly cheese, but really not know about rotten things like rotten herring. Grauenvoll. Hast du einen Vergleich, Rita? Also was für ein also gibt's irgendwas Vergleichbares? Yeah, Handkäse. That's actually good. I like really like also good cheese from France. I mean it cheese the worst that can happen with cheese, it smells like fart, basically. Or old feet or something. But it tastes great. So or mold. Mold, fart, like Limburger would smell like fart. The whole Handkäse. That's based off quark. I don't know what is quark. Cream cheese. Not no, it's not cream cheese. It's like this. Oh, okay. I won't eat that. Sorry. That's my limit. Oh, yeah, or there's Mildenkäse. So that's not actual cheese. It's like made from the excrements of lice or what? Okay. Maybe later, not now. Let me. I need to debug this now. Okay, CLK. There is. Okay, fermented. Okay, there is no. I think there is nothing happening here. Oh wait, I need to download it first. Uh-oh. It failed. What? Why did it fail? Let me check. You want to watch me failing here. Whoop, whoop. So I'm trying to program the blade now, and I need to check if I switch the lines. CLK is this one. No, that should work. Sauer, Salzgurken. Reset. Okay, let me check if I can use the flash tool to read. Yeah, I can read the address. Oh, now it wrote. Okay, maybe there was a short or something here. Fermented honey sounds like fermented honey? Never tried that. Okay, yeah. Let me check clock. Yeah, there is no clock. Okay, the problem is that D0 is very difficult to work with. So what we got here Oh, yes. Yeah, let's watch it now. Oh, shit. I can't make it loud. Yeah. Wait. Okay, but there will be TTS now.
We hear nothing, lol.
2 points.
Chicken in the basket.
Ah, die Hühnersuppenszene XD.
We hear it now. Ah, there it is.
Popcorn. What is popcorn? Trained professional.
First step over the corn, the shrimpies. Shrimpies. The shrimpies. Oh, the shrimpies. Oh, the
Space Cowboy, shut
There's a
up.
little resemblance of Johnny. Johnny, you have a little resemblance of the Swedish cook. He has a KitchenAid. Advanced here.
Selbstdissing XD.
Oh, okay, let's
Unfair.
check.
You can see exact like counts LUL.
Oops, I turned off TTS again. Here we go. Who is Swedish? Wait. Oh, yeah. Kommt in Kläranlagen, Versorgungseinrichtungen und Abwasserkanälen vor. Surströmming. Oh, half Greek geek. You have to talk to Johnny. Hey, Bachla. Sweets. Okay. Somehow I can't search. Yeah, Christian also, yeah, we know. Okay, so microcontroller clock output, MCO pin, but we have the in config register CFGR0 PLL clock sys clock bus peripheral. Okay, so now MCO, no clock external, no, this is not what it is. PD0 PD0 PD1, okay. Here we go. Can be used of GPIO, which is achieved by setting remapping register AFIO PCFR1. This remapping is only available for blah blah pin packages, which is one of ours, has only OST and own functions pins, does not support mapping. There is no need, blah blah blah. Okay, I tried this. I think I have even code for this in the code already. So obit configuration, remap register. Remap register is basically here. Remap bit PD01 remap bit, which can be read or written by the user. It controls whether the GPIO function. It controls whether the GPIO functions are remapped. D0 and D1 are remapped in okay, is crystal pin 1. So we need to set this one remap to 1. And I think I did this, but not in this implementation here. CFR D0 remap and IFO, oh yeah, peripheral. I tested this and I couldn't make it work before. Let's check if I got the right register. PCFR1. Attoseconds. Now we remapped that. Let's try again. Cluster blade. Whenever I see a clock, we will plug it in and then have it working. Okay. And that doesn't work at all here. Oh. Flashing takes a second. What are you talking about? Now it flashed. Okay. Yeah. Yeah. Let's see. Only we just need looking for the clock here. Nah. No stable clock here. Oh wait. We can do ground. Where is ground? I have no clue which one is ground here. This one is ground. But basically what happens now is nothing. Okay. This still doesn't work here. Still doesn't work. What I think is we need no, not suddenly. It's not suddenly because we are now programming the blade, not the blade base. And that uses a pin that's a bit difficult to work with. So that might not work. So we might need to use an alternate function here. Alternate. I'm not sure if there is maybe someone can find informations about the D0 and D1 pin to be used as an GPIO on the CH. Yeah, no, there's no such thing. GitHub. That's that. Here. That's the 3. Anybody? So we have several options here. We make that work, or we reconfigure the pins and make a botch somewhere using a different pin for that. But this is not helping me. Not capable of doing that. We could also use this board, dev board, which is easier to debug. But I would try to use alternate function first here. Wait. Where's my code? This is my code. So initialize as alternate function. Where's my CH? Not doxing here or anything. CH32 V reference manual datasheet. Okay, here we go. Okay, here. Oh shit. I might want... I want the English version. Oh, still both. I need the English version. Let me check. Datasheet. Let me check if I can get the datasheet in English, please. Reference manual. Here we go, English datasheet. Pin outs, pin definition, and we have pin description, main function and alternate function. So that's the other version, QFN. We have, why is my nose itching so much? I'm now middle-aged, a middle-aged man and have nose hair that's tickling myself. Where is QFN 28? Now what version do we have here? Second puberty. Oh no. That's the worst. Where is it? PD0. Okay, ear hair. Oh no, please not. Pin unconfigured OS function pins by default after chip reset. Software can reconfigure pins as D1, but for those in package, since there are no need to re-image settings, blah blah before blah blah blah. Okay, we got that. Huh? Where's huh? Where? D0 oscillator in can. Oh, that's, yeah, that's the capabilities. It can be mapped. So remapping function. That's not alternate function. That's remapping function. So this is quite hard. How do I do that? So what? That's the node 4, but it doesn't work. I never saw that actually working. I already tried. Node number 4. Yeah, this is what we read again. So there is no new information. It's not alternate function. So how do we make it work? We can try to, oh no, there is a crystal, so we can't use it here. Or we use the crystal-less version. But we also have it set up, so system, we can check internal oscillator, so that doesn't help. Oh, it's not 6 times, it's 3 times faster. 48. Yeah. I have to fix my script for that video. Shit. Yeah, no, this is not. GP0. Maybe we ask CH32V D0 remap. What? This one? 8 megahertz. Yeah, there is probably no remap. No, that's remapping. That's the boot area. How someone figured that out? I mean, the boot area. We can still check that. Wait, that's the data sheet. That's not what I wanted. Where am I? Where's the datasheet window? Someone who has the information on that chip and or the chip there and can find out for me if it's possible. Nice, Polish. You can help me. You can help me reconfiguring. So GPIO D0 doesn't work. We can't make it work. So what we can do the following. We can just set it high. So set clock 1. Yeah, this will be C1 shift left 0. Yeah, that's D0. We can even we can just do it down there. So to be just sure, and do like we set all the lower bits. I don't care. So this should initialize it. I have no clue what else we should do there. Oh, yeah, we need to do this init structure. Here in the beginning. In the beginning. Ja, die kenne ich. Ich bin da oft genug gefahren. Oh, okay, that's not working. It's low. Oh yeah, DR, out DR. You know, I don't know how to configure it. Maybe you can find something about that, but it just is low. No matter what I do. GPIO 0. D01 remap. Which is correct. It's 80. So it's the highest significant bit of PCFR1. Let me check that. Remapping register. 15 D1 remap. That's that. There is no 15 remap bit. Need to write it control server GPIO remap. $64 packages. This is like how many pins do we have? That's like 48, I think. Yeah. There's nothing else. Maybe we can change the order. Let's try to initialize it first and then remap. Yeah. I think it's 48. We can see that in on here. Yeah, that's the 48 version. Here is the 48. I have no clue how to fix that. AFIO. It's a really strange problem because the datasheet and the reference manuals say you can do it, but I never saw it working. It doesn't do. Wait a second. Oh wait, peeps, I forgot to pull it down. It's not plugged in. The pull down happens, the pull down of the clock happens on this. So no, but is it, are we doing, good night Christian, are we doing open collector? No. Wait. Oh, sorry. There is also no structure here. OD mode. Let me do push pull. I forgot that one as well. Shit. Okay. Yeah, that's not happening. Okay, let me do that. This is now open drain. Let's do push pull. Without, let's see, I need to be sure. Nah, this is not pulling anything. Oh, we didn't upload yet. Okay, you look, you're looky, and I uploady. Here, boom. Oh no. Can't connect. Come on. Be more cooperative. Nope. Nothing happening here. Shit. It's now in push-pull mode. Open drain. Let's do open drain and set it to 0. We can set it to 0 and then put a pull up. Oh wait, we need to put it in endless loop here, and I will use a pull up resistor. Here, I put a pull-up to 3.3 volts. I don't know what resistor that is. So you watch here. There, I just put a resistor on the clock here. Yeah, yeah, but we do out the R afterwards. So okay. Okay, it's pulled up. It's not pulling low, pull down. Pull down doesn't work. It's here is okay. Let me show it. Here is low, there is high. It's on the high, so it's the same, like 3.3 volts. So it's not pulling down. It's not doing anything. So why? Why? Okay, sanity check. I will check if it's even connected to whatever with the beep meter. You want to see collisions? I will give you collisions. We just configure a different pin, and I have already a fallback pin discovered. I will show it because Kaspar, before you go brushing your teeth again, I have a fallback for you. So what I can use, what I did here is for programming the superclusters. We have, is this the cluster blade? Yes, cluster blade. I think I put somewhere SDI, SWI somewhere here. Not that one. That one is to program it. Or we can repurpose the reset, because we're not using the resets anyways, for now at least. We can repurpose any pin. Where's the SDI? We had no SWI. I thought I had it down here somewhere. No, it's not there. That's, but it should be. Uh-oh, there is no. That's the command for the other one, for the highest thing. Good night, Rita. CLK0. Yeah, what can we repurpose here? We could basically, you know what, we could basically connect CLK to any other pin. And we could use basically something that we never use otherwise. The reset pins on this supercluster, we're not using those really. Reset command. This is the other command. Oh, wait. Yeah, we are not using this command anymore. This is the command for the other one. So we could actually use PB3 instead of that, and we could short it with, or like connect it to the command pin on. But how to find it on here? Oh man, this is hard to solder. I don't think we have this pin really exposed anywhere, like the clock 0 pin. Clock 0 pin is not exposed except for on the connector down here. CMD to, yeah, it's so this CMD of the supercluster is basically is still usable, but with the new protocol we don't use it anymore, so we can repurpose it. It's a wasted pin for for the supercluster, but oh well, that's how. Or we just reuse any other pin. But I'm really wondering why it is not working, because that should be working. It's there. It's defined like that, this pin. No clue why it's not cooperating. Oops. F in its structure. Open drain. Pin 0. So let's look inside. GPIO mode. GPIO config. Wait a second. I need to check something. Maybe I forgot another part. Hey, DeMarcus. I actually forgot something here. Please don't punish me. Oh, nice. Yeah. I forgot to turn on the peripheral. I hope. Let me remove that. Oh no, it's open drain mode. Yeah. Oh man, Elon Musk is going nuts right now. Damn, he posts such a shit on X all the time. No, I don't support X. I call it Twitter, just to troll him. Not that he would care at all, but... Oh well, okay, now... Oh, the link isn't connected. Twitix. All right, let's take a look. Oh, fool. Doesn't. Yeah, it's the same. Yeah, we can check. We can check with that one here, but there is a crystal attached to that pin, so it's not that well suited to test that. But I mean, all sources of errors should have been eradicated now. Peripheral clock command. Enable clock command, enable peripheral. Wait, what's the difference? Wait. That resets and that's Okay, yet another Yet another possibility here that I have broken code. Let's wait a second and try again. I don't know why it's refusing to program the first time. Please be low, please be low, please be low, please be low, please be low. Nope, it's high. Foo. Shit. Ah. Aus Österreich. High-speed ABP, peripheral clock. I have no clue actually. I don't know if there is like... You know what? Let's check if I can find the zip file. WCH page, PF related documents, development source, Wien, nice. Shit, where is it? Not datasheet, I need this one here. Okay, I'm downloading the examples. Maybe, let's hope there is something with the GPIOs, or we can see a unit test or something. Oh, wait. Example. GPIO toggle. Okay, peeps. There is something like that. Yes, overwrite it. I don't care. Show me a life hack that completely changed. Ah, damn it. Ah, look at that. There is this chip ID thing. Yeah, but what? GPIO toggle in it. Nudelholz here. Pin 0, push pull, 50 megahertz. Peripheral clock command. Peripheral clock command. Peripheral clock command. AFIO. Okay, I need to... That's a meme on my... that's a meme on one of my videos. I even brought it to merge here. So the roller pin on the keyboard is hacker mode. Yeah, but I really like the laptop. Oh really? You can check on merge shop. I don't know, even like link.bitluni.net/merge is I think the merge shop. So what I like more it's really cheap. It's really cheap. So don't expect like a high super great thing. But I'm using that myself all the time. So this is like a really basic and really cheap bag. But yeah, it has like this subtle bitluni lab crew thing. And then inside of that, it's just oh, what are these? Tools and good night, Ishibu. All right. I have no clue how to work with that, with this AFIO. Let me... Haribo? No. No Haribo. But I got that one here. A current metering system. Whatever. ESD, yeah, that's that's the badge, the Hackaday convention badge. I didn't even like open it. Because, yeah, I didn't want to do batch hacking and I have this already. Yes, inductive load. Oh. Oh, here is my power bank. Nice. Okay, whatever. This distraction. I don't see in the examples. Let's check the examples. So, there's only one example about GPIO, so touch keys at USB, no watchdogs, RTC, RCC. What is OPA? What is RCC oscillator? What? HSI MCO. We will check all the Kleingeist, yeah. MCO. Let's see. Priority group config, system core clock update. ID peripheral. That's a RCC MCO. Oh, maybe we have something. Sehr familiär, ja, ist das. Das liegt daran, dass wir ein recht übersichtlicher Haufen sind. So it's very like cozy group of people. Maybe there is a function that enables us to. That's RCC. I don't know. No clock. No clock config. If we look for, let's check that, or that in RCC, maybe we find okay, define MCO, define, there's nothing. RTC only defines. I don't know how to use How do I use local search? I don't want like the whole workspace. Nope. Okay, let me check a different example. PLL source. Yeah, but this will not. Oh, that's all? You just define it or what now? Yeah. I have no clue how to reconfigure that properly. I can do a botch maybe, but that's hard. Or we call it a day for today. You wanted to see collisions. Oh damn, I'm so sad I can't show. What's the pin name again? OSC in You're not sure about that? But it's like the 16th bit and it says we need to set it to 1. Yeah, library code. What does it? Where does it say that? Yeah, that's. In a comment everywhere, you found what? Oh, what? Oh wait. Where's the space? Port mapping on. Yeah, that's what we want. We want D0 and D1 to be mapped to those pins. Or vice. You mean we need to clear it? So it's inverted. Is it? It is. You mean we should try just resetting it? Yeah, we can try all the permutations. We can do a program that writes a random. No. Yeah. Yeah. Wait. Can do that. I'm just flipping it, so that could be anything. Check that will not. No. Ah. And push pull. Nope. Can also GND that. So. Yeah. Okay, what happens? I think I will give up for today. Okay, I have one more shot at this. So, by the way, if you were asking here, bit 15 is remap. It says 1 pins are used as GPIO ports. So it should be really high. We can check if I configured this AFIO correctly. So this is going 8. No, that's external PLL. Yeah, that's only for the clock configuration. Yeah, no. That has nothing to do with that. Okay. External clock. I think I tried this once using the external clock source, but that doesn't help us really. Can be used. Nah. I have no idea what this peripheral clock command. Peripheral clock command, peripheral. Oh wait, AHB, APB. Maybe we are on the wrong bus. Uh-oh. Okay, let's check that. HPB bus 2. Oh. Let me do that. Let me check. That's like which bus? No, it's BB2. It says AFIO. But is there an AFI? No, AHB peripheral. There's no AFIO. AFIO is on HPB2 peripheral. Damn. And there is also no AFIO. Oops. It's so complicated, huh? Clock command. Oops. Open declaration. Okay, HPB clock command. Peripheral reset command. Reset. Backup. Reset. RCC backup. External. Oh, just me. That implies, yeah, we're doing that, I think. Because writing, we are operating at 32 bits. I think it's used by it's using by default the whole 32 bits. You in 32 here. We are compiling 32-bit mode, so this, yeah, it's also 32 bits. So yeah, in that case, let's do it again and set the flag, because I think the other way around was correct, but still we are not seeing any result. No, okay, let's write it again. But just me, you were lurking. Thanks for trying to help me. I don't see a result here. Oh wait, we have the pull up and push pull mode. Let's do, yeah. No, there's nothing happening. That's basically dead. It's dead, Jim. Oh, I wanted to check if it's routed correctly. So sanity check that the pin is even connected. It might not be connected at all, and I don't see anything on the That would be funny if it's not connected to the connector here. Wait, this is the segment 0. It's here. Where is it? That's pin 5. I will debug it and find it out, but I would really love to show it to you today. Damn, it's a little bit sad. Pin. It's hard because it's on both sides. That looks like it's the 5th pin. Oh yeah, it is the 5th pin. Okay. So no. It's actually correctly set up. Okay. Let me do it like that. I do a quick fix. I will solder a botch wire. Yeah, there is no way you can see what I'm doing. A botch wire here, so I can test it at least. Okay. See you tomorrow. Yeah. I hope I'm fixing the right one here. Yeah, it was fun. Bye bye. Oh, this is so hard. Then I need to set up my microscope again. I can't even see properly here because it's so. My lab is still in. In backup mode here. Good night, Caspi. Here we go. It maybe. Uh-oh. Uh-oh, that's... What pins did I short? I shorted 2 pins. Let me check. It will be alright. PC in and PC out, OSC in, OS in and OS out are shorted. I don't care. If it works, it works. If it doesn't, it doesn't. Let's hope it's still booting. And where is the pin? The command pin. I need to find the command pin. I want to use that one. BP3 might be, I'm not sure. I have now, the wire is now like stuck between pin. Oh wait. Oh yeah, osts in and osts out. Oh, that's 32 in and 32 out. That's like a different one. Oh man, this is... Yeah, I don't care. Oh, what is this? No. Here we go. Where is the comment? Let me find the comment bin. Let me find... Comment is here. Okay, I found it. That's a little bit easier to handle. Oh no. It's soda. Ah. Need some extra paste here. Where's my paste? Okay. I hope that still works. And now we need PB3. Open drain, PB3. Oh, yeah, we need to push pull. PB3. B. Can you even see what I'm doing? I have no clue. Oh yeah, you can see. And download it. That worked, but let's see the result. Meh. I hope it was the right one. Oh, I'm not setting the right register here. Yeah. One moment, please. Some fresh air here. I think I disable soldering iron. Yes, it has to do with Lunatic, because that was my initial handle in the demo scene, but it isn't very unique. Like everything about Lunatic, like you can't have a domain or whatever. And I was looking for a brand when I started like my YouTube channel more seriously. I had like a different channel before for a few months, and I thought, okay, I need now like really a brand that I can build up that is unique, where I can register actually the trademark, and that's record label. Yeah. No, Lunatic probably. No, it has nothing to do with any other artist except me on demo scene, but also at some point in the demo scene my name was shorted to Looney, and everyone calls me Looney actually. And also in real life many people, like friends, call me Looney because it's the easiest. And a bitluni is the brand name or the name on YouTube. Yeah, I don't see. I hope I botched the right one. Yeah, Farbrausch. Not. I wasn't that good as Farbrausch, but we did some intros. I think I programmed the wrong thing here. S1, S0. Reset 1, reset 0. Miltenberg. Ich wusste nicht, dass da eins ist. Okay, I don't. Oops, I think something. Reset 1 and reset 0. That didn't work properly. I'm not sure. Okay, pips, it doesn't work. I have no clue. I don't see anything happening. I must do. Okay. Thanks for the recommendation. I'm not sure if I can make it work today. Yeah, I think so. R1 and R0. R1 and R0. Clock and IO. Yeah. I uploaded it to both. Nah, I have no clue. Sorry. I'm not sure if I can make it work today. So let's keep it at that. I will debug it offline, try to find more resources, and hope that next stream we will be seeing some collisions, okay? I will call it a day. It's already like 12 o'clock, and let me check if we can raid someone. So, who is online? Of the Twitch homies. Yeah. Let's raid someone. Hoffman is online, okay? Let's do Hoffman. See you. Yeah, no worries. Thanks for joining, everyone. It was a blast. Unfortunately, we figured out, like we did some work, figured out everything, and now we need to tackle the problems with the chip that isn't so easy to program. All right, see you next time. Bye, and have fun with the raid on Twitch. Bye bye. Okay, now let's still streaming. I know. Looking for the streaming window, live stream here. Okay, I think this is the one. Yeah.